Today we shall be discussing on linear motion. Linear motion tackles issues like relative motion. So under relative motion, we have relative speed. Relative speed is normally determined according to the nature of motion of the two bodies. For example, if two bodies are moving in opposite direction, you can say this one to be body A moving in this direction, this is to be body B moving in opposite direction. The relative speed becomes the sum of their speed, that is speed A plus speed B. Then you also have relative distance. Relative distance is the distance between the two bodies when they are moving at the same time. That means if you have maybe a distance to be covered, body A can be moving from this point towards this point. Let's say this is body A. Then you have another body B that is following it after some time. So the distance between the position of body A and the position of body B is what we call relative distance. That is for the one going in the same direction. We can also have a relative distance for the opposite direction. If this is body A, this is body B. So the distance between them to be covered is what we are calling the relative distance. They must be moving at the same time. For example, if another one leaves at 7 a.m. and then the other one leaves at 8 a.m., you're supposed to find when they are moving at 8 a.m. because that's the time when they are all moving. Then you have relative time. Relative time is the time taken for the two objects to either overtake each other for the one moving in the same direction or to meet each other for the one moving in opposite direction. So remember, from time, relative time is equals to relative distance over relative speed. So let's move on to examples. A bus left Kisumu for Nairobi at an average speed of 60 kilometers per hour. After 1.5 hours, another car left Kisumu for Nairobi along the same route at an average speed of 100 kilometers per hour. If the distance between Kisumu and Nairobi is 500 kilometers, so you have to determine the distance of the bus when the car took off. Remember, the bus left earlier at a time of 1.5 hours. Therefore, it had covered some distance, which is given that the distance covered by the bus before the car is equals to the speed of the bus times the time taken before the car departing. That becomes the speed of the bus you have been given as 60 kilometers per hour. Then the duration taken is 1.5 hours. That gives us 90 kilometers before the departure of the car. The second part of the question, the distance the car traveled to catch up with the bus. We want to see which distance did the car cover to catch up with the car. In terms of our sketch, we can say that this is the total distance we have here, the bus leaving here at Kisumu. So after 1.5 hours, maybe the bus was here. This is the 90 kilometers that it had covered. So the bus is now at this position and the car is still starting here. So therefore, the relative distance, we have said that it's the distance between two objects when they are all moving. So the car is now starting here. So the relative distance becomes 90 kilometers. Relative speed, they are going in the same direction. If they are going in the same direction, you have said the relative speed becomes the difference. It becomes 100 for the speed of the car minus 60 for the speed of the bus, leaving us with 40 kilometers per hour. Therefore, relative time or time taken for them to meet becomes the relative distance, which is 90, over relative speed, which is 40. And that one from the calculator gives us an answer of 2.25 hours. Then this is also the time taken for the car to travel to catch up with the bus because relative time. Therefore, the distance covered by the car is equal to the speed of the car times the time taken for them to catch up. That means you're talking about 100 kilometers per hour as the speed of the car, then times 2.25, which gives us 225 kilometers. So the car traveled 225 kilometers to catch up with the bus. Then the last question here, immediately the car caught up with the bus. The car stopped for 25 minutes. Find the new average speed of which the car traveled in order to reach Nairobi at the same time as the bus. Remember, it stopped for 25 minutes while the bus was still moving. Therefore, the total distance was 500. The car covered 225. So the remaining becomes 275 kilometers. So therefore the time taken for the bus to reach Nairobi becomes time is equals to distance over speed. So the remaining distance is 275 divided by the speed of the bus was 60 kilometers. Then from the calculator again, that leaves us with 4 hours 7/12. Then the car stopped for 25 minutes. 25 is the same as 25/60 hours. So therefore the car is now supposed to move at a faster rate to cover these 25 minutes wasted. So you now come and say that the time taken by the car is equals to the time taken by the bus, that is 4/7/12, then minus the time wasted here, that is 25/60. That leaves us with an answer of 4 hours 1/6, or 4/6 hours. Therefore the speed of the car is equals to the distance covered, that is 275, divided by the total time taken, that is 4/1/6 hours. That gives us 66 kilometers per hour. Therefore if the car covered 66 kilometers per hour to reach the same destination as the bus, but to the nearest whole numbers, it becomes 66 kilometers per hour. The second part is the graphical analysis. We have here also a question that the graph shows the speed time graph for a train traveling between two stations. So the train starts from rest and accelerates uniformly for 150 seconds. So starting from rest, meaning at rest is not moving, so the speed is 0. So therefore up to this maximum speed for 150 seconds. This one becomes 150 seconds. It then travels at a constant speed for 300 seconds. So from here to here is 300 seconds. 150 plus 300, that is 450. And finally decelerates uniformly for 200 seconds. So moving from here to here is deceleration for 200 seconds. So it becomes 650 seconds now. So the first question, given that the distance between the two stations is 10,450 meters, calculate the maximum speed in kilometers the train attained. Remember, maximum speed is this highest speed here. Therefore, we now need to know that area under this curve for a velocity time graph or a speed time graph is normally the distance. We now see that area, which is given by a half h into bracket a plus b, because it's a trapezium, is the same as the total distance, which is 10,450 meters. So it's equals to now a half. So it doesn't know the h into bracket. So this is the parallel side, that is 650, then plus this one from here they have said is 300 seconds. That means that 10,450 is the same as 475h. So dividing both sides by 475, you get that h is equals to 10,450 divided by 475, and that leaves us with an answer that is 22, that is meters per second, because this one is in meters per second. So therefore we have it in meters per second, but they want the answer in kilometers per hour. So how do you convert? We simply change. We have 22 divided by 1000, that is change from meters to kilometers, then divided by 1 second divided by that 600, that is also to change from seconds to hours. That means in kilometers per hour you will be left with 22/1000, then times that 600/1, and that gives us a speed of 79.2 kilometers per hour. As simple as that. Then the second part of the question, the acceleration of the body. The acceleration is normally the increase in velocity with time. Therefore it's from 0 to this one that you have found there. So acceleration is given as final velocity minus initial velocity over time taken for the change in velocity. That becomes final velocity. Here you have found it to be 22. So 22 minus the initial velocity, which is 0, divided by time taken, which is 150. And that one again, using your calculator, gives you 0.1466 recurring, which can be written as 667. That is in terms of meters per square second. Then the distance the train traveled during the last 100 seconds. So the last 100 seconds can be found from here. So you can say from 650 minus, it becomes 550 here. So 550, you can say it is somewhere here. So it doesn't have the deceleration, so you're supposed to find the deceleration because it is uniformly. The deceleration here is the same as the deceleration taken throughout. So therefore, deceleration is normally the negative of acceleration, which is also now the negative of the final velocity, which is 0. Final velocity minus initial velocity over time taken. That means that 0 minus, we doesn't know, we know the velocity here is 22, so 0 minus 22 divided by the time taken, which is from this point to this point is 200 seconds. That leaves us with an answer that is 11. So 11 meters per square second. Remember, it is negative acceleration, so that's why you have not included the negative. Then to find out the velocity at this position, we still say that the deceleration is the same, so therefore negative 11 is the same as the final velocity, which is 0, minus the velocity that we doesn't know, the velocity at 100 seconds, then over time taken, which is 100 seconds as required from the question. That means multiplying both sides by 100 to remove the denominator or cross multiplication gives us negative v is equals to negative 11. This was 0.011, negative 11. Therefore, v is equals to 11 meters per second. Therefore, the distance traveled now, if here is, you can say this one is 11, this is 11. So drawing that triangle becomes of this kind. This is 11, this is 100. So area under the curve is a half times 100 times 11, and that leaves us with a final answer, which from the calculator is 550 meters. So remember to change this one to be 0.111. This is also 0.1. This is 0.1, so that you now get the correct answer there. Then the time taken, the time the train took to travel the first half of the journey. The first half of the journey, you know that the total journey is 10,450. Therefore, a half of the journey is a half times 10,450. That gives us an answer that is 5,225 from the calculator. That means 5,225 kilometers is the same as half of this journey. So you can say a half is at this position. So remember, at this position, we are sure of the area of this triangle. Then it is the area of this triangle, then plus the area of this rectangle. Remember, this triangle from here up to here is 150. Then this rectangle from here up to here, we doesn't know the time, so just say it is t. Then the height here is 22, well known. Therefore, it becomes a half of the area of this triangle is a half times 150 times 22, then plus the area of this rectangle is length times width, that is t times 22, so plus t times 22 to get this answer. Collecting like terms, it will give you 5225 is equals to 1650 plus 22t. Then collecting like terms, this one goes the other side and gives you the 22t is the same as 3,575. Dividing both sides by 22 leaves with t as 162.5. Remember, this t is t that you placed here. Therefore, the total time for half of the journey becomes this t here plus 150. Therefore, half of the journey is equals to 162.5, then plus 150, leaving us with a total time of 312.5 seconds. Remember to drop a subscription, and if you have any question, you can simply contact 0707479356 so that we grow together. Let us grow together.